We're now going to look at completing the square. Now, I will be completely upfront and transparent that completing the square is a terrible way to solve a quadratic equation. We're going to look later about how completing the square helps us get the quadratic formula, which is a much easier way to solve any quadratic if we cannot factor the quadratic or if it's too difficult to factor. But this skill is crucial for future sections and different skills that we're going to be doing in the future. So we're going to practice on easier equations before we move to much more difficult ones in later chapters. Think of this unit as learning to ride a bike with training wheels. These are the training wheels. Later we're going to take them off. But we need to know how to do it first and get our balance before we move to more difficult equations. Completing the square involves rewriting one side of the equation to be a perfect square trinomial. A perfect square trinomial then always factors to be a binomial squared. A binomial squared is what we need in order to have vertex form. So our goal in completing the square is less about being able to solve the quadratic equation, but more about being able to rewrite the quadratic from standard form into vertex form. So let's review how we even get a perfect square trinomial. Perfect square trinomial has to follow the pattern where the first and last terms are squared, and then the middle term is always 2 times the root of the two terms together. And so we can use that idea to help us figure out, well, what does our constant need to be in order to have a perfect square trinomial? So here we have x squared plus 10x plus something. And we need to know what number goes here. Well, we need to remember that this number needs to be a perfect square. It needs to be a square of an integer. And this middle term, more importantly, has to be 2 times the square root of x squared, which is x, and the square root of our mystery number. So we have to think about, well, what number makes this true? Well, the x is already cared for. So here we look at 10 divided by 2. That gives us our mystery number of 5. So 2 times x times 5 gives us the 10x that we need. Well, 5 is the square root of 25. So we can find our number by taking this value, dividing it by 2, and then squaring it in order to get the constant. And now that it is a perfect square trinomial, we can factor it into a binomial squared. Our binomial squared will be x, either plus or minus y, quantity squared, and that plus or minus will match from the trinomial. Well, as part of this process of trying to find what that number is, we've identified what x and y are, x and 5. And so our factor actually ends up being x, we're going to take the plus sign, 5 squared. So that ends up being our factors. Let's look at the next one. So 12x needs to be 2 times x times something. Well, 12 divided by 2 gives us 6. So our missing number is 6. 6 squared gives us 36. And our factor ends up being x plus 6 squared. 6m needs to be 2 times m times something. Well, 6 divided by 2 gives me 3, and 3 squared is 9. And our factor ends up being m minus 3 squared. And for every single one of those, in order to get a perfect square trinomial, we took the b value, we divided it by 2, and then we squared that quantity. That's our formula for completing the square. So we're going to be using that formula a lot. Let's go ahead and actually complete the square for each of these, and then we can use the square root property to solve. Now, there's a couple different ways that we can solve by completing the square. The main differences deal with how differentiate on how the constant is dealt with, and also how a leading coefficient is dealt with. So you may see some other methods, and they're viable when we're trying to solve a quadratic. But remember, our goal isn't just to be able to solve a quadratic, but it's to take a quadratic in standard form and rewrite it into vertex form. And so the method that I'm going to be using is geared very directly towards following that process, but also making it easier for us to solve later down the line, and even when we want to deal with conic sections much further down the line. So the first thing we want to do is we want to get our equation to look something like what we had up here, where we had this blank space that we could deal with. So we want our equation to look something like this, which means we need to take this constant and we need to kick it out and move it to the other side. So if we subtract both sides by 10, we get x squared plus 8x, and then our blank is just going to be a box. And I use a box to remind us that we are completing the square, so I draw a little square. Negative 10 plus, I can add whatever I want to my equation as long as I do the same thing to both sides. Now, to determine what goes in that box, we're going to use our formula. The box is going to be b divided by 2 squared. That's that blank that we filled in our perfect square trinomial. So we look and we see, well, our b value is 8. So 8 divided by 2 squared. 8 divided by 2 is 4. 4 squared is 16. So we put a 16 in both boxes. Now that we have a perfect square trinomial, x, keep this sign, plus, and then this value is always going to be the square root of c, but keep in mind we had to square something to get there, so we already know what that value is. And that's going to be really useful, especially as we end up with some more complicated values for the constant with some fractions. Knowing that we've already squared it before, we just have to go back a step to get the number for the factor. So x squared plus 8x plus 16 equals x plus 4 squared. We simplify the right side, and now we have an equation in vertex form. We've completed the square. We have a quadratic in vertex form. We can use our square root property to solve. We'll square root both sides. X plus 4 equals positive and negative square root of 6. Subtract 4 from both sides. X equals negative 4 plus and minus the square root of 6. So we've got our two answers. Negative 4 plus the square root of 6 and negative 4 minus the square root of 6. Let's go ahead and try it again. First step is to move the constant to the other side. And we're going to draw our boxes. Now our b value, this time, is 5. So 5 divided by 2 doesn't simplify, which is fine. Reduce the fraction as much as you can, but leave it as a fraction if it doesn't reduce all the way. We're still going to square it. And so we're going to get 25 over 4 in both of the boxes. So from here, now we have a perfect square trinomial. It's not pretty, but we have one, and now we can factor it. X plus something squared. Well, remember that something is going to be the square root of the c term. The square root of the c term is the term before we squared it. So it's x plus 5 over 2 squared. On the right side, we can go ahead and add, and we're going to get 29 over 4. Now we've completed the square. We can use our square root property to solve. Square root both sides. X plus 5 over 2 equals positive negative square root of 29. Square root of 4 is 2. And we subtract 5 halves. Negative 5 halves plus and minus the square root of 29 over 2. You can leave it as two fractions, or you can combine them over the common denominator. Either one is fine.